Hello everyone, I Rachna H. Kalapnavar, lecturer in Electrical and Electronic Department, Jain Polytechnic, Belgavi. Today in this video, I am going to cover about formation of NPN and PNP transistor from transistor and MOSFET unit. For more videos, subscribe my Architect YouTube channel. Next, what are the contents of today's video? First will be working of NPN transistor and next is the working of PNP transistor. So first, before I start with the NPN transistor, last class what we discussed about in the last unit, last video. What is transistor? Transistor is a semiconducting device. It is having a 2 PN junction and 3 terminals, emitter, base and collector. You can see in this image, here is one PN junction and here is one more PN junction. So 2 PN junction and 3 terminals, emitter, base and collector. How it is a working of NPN transistor? Here it is having a two type of transistor. One is a NPN, next is a PNP. So NPN means P type material sandwiched between two N type material. PNP, N type material is sandwiched between two P type materials. So before I start with this, we have to give the supply voltage, DC supply to the transistor. It is called as the biasing of transistor. Biasing of transistor works on three regions. One is the active region, cutoff region and next is the saturation region. What is the active region means? See here, emitter and base junction should always forward bias and base and collector junction should be reverse bias. That is the first condition of active region. Whenever we have to connect the transistor in the active region, emitter base junction should be forward and collector base junction should be reverse bias. That time it is a work as an amplifier. If you are using the transistor as a switch, then it should work in the cutoff and saturation region. Cutoff means emitter base junction reverse bias and also collector base junction also reverse bias. And saturation means emitter base junction forward bias, collector base junction is forward bias. Here we are connected in the active region, that is a emitter base junction should forward bias, collector base junction should reverse bias. What is the meaning of forward and reverse bias? Forward bias means N type material should connect to the negative of the battery and P type material should connect to the positive of the battery. It is called as a forward bias. Reverse bias means N type if it is connected to positive and P type is connected to negative, then it is called as the reverse bias. Here you can see here this section, that is emitter base junction is forward bias. N is connected to negative, P is connected to positive, and next here it is a collector base junction is reverse bias. N is connected to positive and P is connected to negative. So this condition, it is a compulsory condition of the transistor to apply as an amplifier. So what happen if you connect like this? Then what happen? Electrons, whatever the emitter, in the emitter side, N, we are using a NPN means here N section is there. In the N section, electrons are majority charge carriers. It will start to moving towards the base section. In the base, what happen? It is a lightly doped. As the emitter function is supplying the electrons, base is lightly doped and here it is a holes will be there. Only lightly, very less number of holes will be there because in the P type, holes are the majority charge carriers. What happen? This electrons will be, while moving to here, it will be recombined, but almost not all the electrons will recombine here. Only few electrons, because it is a lightly doped, only 5% you can assume. Here it is some electrons will be recombined with the holes. Electrons and holes recombination will takes place here, and after whatever the other 95% of electrons will be there, that will move to the collector side, and next collector side it is a collecting all the electrons. So what happened here? Here current, whatever in the emitter section, it is a IE, and here from the outside of the base it is IB current, and here it will be the IC current. So IE, IB and IC are the emitter current, base current and the collector section current. So like this the NPN transistor will be working, and collector current will flow like this. So here we can see that IE is equal to IB plus IC. This is a basic current formula for the transistors. So this is about the NPN transistor. Next we'll see about the PNP transistor. So PNP, in PNP, N is the sandwiched between two p type of materials. In the p type, trivalent impurity will be there, so it consists of majority charge carriers as a holes here, and in n type, electrons are the majority charge carriers. What happened? See here also, emitter base junction should forward bias and collector base junction should reverse bias. Here for to forward bias this junction, we have to connect p type to positive of the battery and n type to the negative of the battery, and here collector base junction should reverse bias, means p type should connect to the negative and n type should connect to the positive. What happen if you connect supply the voltage DC supply if you give, then there will be the whatever the holes will be there, it will start to move to the base side, in the emitter side to the base side. Emitter side is heavily doped, heavy amount of the majority charge carriers will be there, will start moving to the n type section. In the n type, it is a base, as it is a lightly doped, very few holes and electrons will recombine here, and rest of the holes will 95% of the holes will go to the p type section. Again here it is a collection, it will collect all the holes and it will be constituted the current IC, and in the base current it will be constituted the current IB, and here it is starting, it will be constituted the current IE. So it complete the collector side, complete the circuit. So this is about the working of a PNP transistor. Here also I is equal to IB plus IC. This is a current formula for the both NPN and PNP transistor. So I hope you people understood about the NPN and PNP transistor working. Thank you.